1.2 Concept 1 is all about factoring and prime factorization. So looking at 10, we know that 10 breaks down into the factors of 5 times 2. And the act of writing 10 as its factors is called factoring. We can use this factoring. For example, 12 is equal to 2 times 6. But if we want to break it down into its prime factors, that would be 2 times 2 times 3. And those are its prime factors. So the question is, what does it mean to be prime? So the definition of a prime number is any positive integer larger than 1 whose only positive factors are 1 and itself. Examples of prime numbers are 2, 3, 5, 7, and 11, and it continues on and on and on. If a number is not prime, we say it is composite, such as 4 equals 2 times 2. That means we can take other numbers and divide it into that number. It's not just divisible by itself in 1. So we can use our prime factors to help us factor numbers into a product of primes. And to do that, we can make something called a factor tree. So with a factor tree, we look at our number, and in this case, our number is 60, and we say, well, what divides into 60? What do I know that divides into 60? And right away, I think, oh, 6 times 10. So I'm going to take 60, and I'm going to branch it down and rewrite it as 6 times 10. And then I look at those numbers and I say, hey, are those numbers prime? And the answer is no. So I say, well, what can I break those numbers down into? And I can break 6 down further into 2 times 3, and I can break 10 down further into 2 times 5. And what I notice once I do that is that I can no longer break the numbers down. And so my prime factors to 60 are 2 times 2 times 3 times 5. And another way to write that is 2 squared times 3 times 5. So that's 2 squared times 3 times 5. And that is how we use a factor tree to break a number into the product of primes. So we can use this prime factorization technique to help us find things like the greatest common factor and the least common multiple. So the greatest common factor will be abbreviated the GCF, and the greatest common factor is the largest whole number that is a factor of each number in the collection. So we're going to have numbers, and let's take a look at the steps on finding them. So here are the steps to finding the greatest common factor. And our first step will be write each number as prime factors. So 12 can be written as 2 times 2 times 3, and 30 can be written as 2 times 3 times 5. Now these were small numbers, so that was easy to figure out and write. But if you have a large number, you can go back and use the factor tree just like we did with 60. You can do that on the side and keep breaking it down until you find its prime factors. So our first step is to write each number as prime factors. Our second step then will be to list each common prime factor the least number of times it appears. So if I look at my list of my prime factors, I notice that in 12, 2 appears 2 times. But in 30, it only appears once. So I'm going to count that 2 one time. And then I look and I see 3 appears in 12 one time. It also appears in 30 one time. So 2 was a common number and 3 was a common number. 2 appeared the least number of times once, and 3 also appeared the least number of times once. So I count that one time. My next step is then to multiply the 2 numbers together. So I multiply 2 times 3 and I get 6. And that gives me my greatest common factor. So my greatest common factor was 6. And the way to see that is, hey, 12 divided by 6, that leaves me with 2, a whole number, and 30 can be divided by 6, and that leaves me with the whole number 5. Now we can also use our prime factors to help us find something called the least common multiple. And the least common multiple, I will abbreviate as LCM, is the smallest whole number that is a multiple of each number in the collection. So here are the steps to finding the least common multiple. Your first step is write each number as a product of primes. So again, we'll use 12 and 30. And 12 can be written as 2 times 2 times 3, and 30 can be written as 2 times 3 times 5. Then again, we are going to list each factor the greatest number of times it appears. That is step 2. So if I look at 12 is equal to 2 times 2 times 3, and 30 is equal to 2 times 3 times 5, I say, hey, 2 was a factor, and the greatest number of times that it appeared was 2 times. So I'll say 2 is shown 2 times. And then I look at 3, and the greatest number of times 3 appeared was 1 time. And then I also have this factor 5, and the greatest number of times 5 appeared was 1 time. So then I will multiply these together. Well, 2, I need to count it twice, so it's 2 times 2. 3 I'm counting once, and 5 I'm counting once. I multiply those all together, and I get 60. So that is my LCM, 60. This is a method that the book that you guys will have shows, and the software that you have shows. There's another way that you can do it that I've shown students, and so I'm going to show you that as well, and you can use either option. And this is how my method works. If you take a look, you'll see that 12 is 2 times 2 times 3. So again, my first step would be to write each number as a product of primes. And 30, what I'm going to do is I'm going to line up the factors of 30 that line up underneath the factors of 12. So 30 was 2. Well, I have a 2 here, so I'm going to just put that 2 underneath. And then I have a 3, so I can line this 3 up with that 3. And then I have a 5, and that doesn't line up with anything that was in 12. And then I draw my little line, and I come down and I say, hey, I'm going to count this 2 once, I'm going to count that 2 once, I'm going to count this 3 once, I'm going to count that 5 once. I multiply those all up, and I get my LCM is 60. And so that is another method that you can do to find the LCM. Another way to look at this is to look at a visual picture. So if I take the prime factors of 12, that's 2 times 2 times 3, and the prime factors of 30 are 2 times 3 times 5. So I'm going to list all those prime factors, and I make sure I have for both. So there's 2 times 2 times 3, and here's 2 times 3 times 5. And here I circled the prime factors that were 12, and here I circled the prime factors that were 30. And what I notice is they overlap right here. And where they overlap, that is actually the greatest common factor, is where they overlap. And if I take a look at the bigger circle, where it lists all of the prime factors, 2 times 2 times 3 times 5, that tells me the least common multiple. 2 times 2 times 3 times 5 gave me 60. So that was the least common multiple. And that is another way that you can do these problems as well. This concludes Section 1.2, Concept 1. If you have any questions, please make sure that you post them on the discussion board, and I can answer questions for you. Thanks.